How to fit an exponential model to a scatter plot. We have some data, time in minutes and temperature in degrees centigrade, of a cup of coffee that has been cooling for about 20 minutes. So we create a scatter plot and also plot the function y equals a times b to the x minus h plus k. To adjust a, b, h, and k, we create 4 sliders and do it in this order and adjust them in this order: H, K, A, and B. First, think of this scatter plot as an arm where this is the hand and this is where the arm connects to the body. Then we're going to choose an elbow. The choice of the elbow is arbitrary, but probably would be somewhere in here. Let's pick this as the elbow. The x-coordinate of the elbow is h. So we come over to picking this elbow. The x-coordinate in this case is 8. Next, adjust k. K is the height of the horizontal asymptote. It appears that the coffee is cooling off to around 20 degrees. So this would be the horizontal asymptote. So change k to 20. Next, A. A is the distance from the horizontal asymptote, the vertical distance from the horizontal asymptote up to the arbitrarily chosen elbow. In this case, that looks like it's around 10 units. So A is 10. Lastly, we'll set B to start off with to 1. That would mean no change at all. We can see from the scatter plot that it's decay, so B is going to have to be less than 1. It's going to have to be between 0 and 1. So let's adjust the slider. Often it's not so easy to get it just to the right spot, so you hold down Control and zoom in. So you have a lot more control that way. And now we can do some fine-tuning. I said earlier that the choice of the elbow is arbitrary. We could have chosen this point here. If so, the x-coordinate of the elbow would have been 6. Notice k doesn't change. The height of the horizontal asymptote doesn't change. But A does. That's the distance from the horizontal asymptote, the vertical distance, up to the arbitrarily chosen elbow. In this case, that appears to be more like 15. Let's slide that over to about 15. Maybe a little bit bigger. And B, the decay rate, or the decay factor rather, does not change. So K and B don't change with the choice of elbow, but H and A do. And lastly, how about if we had chosen this as the elbow? Well, in that case, H would have been more like 4, and A, the vertical distance from the horizontal asymptote up to the arbitrarily chosen elbow, would have been bigger. It would have been more like 25. And that's how you fit an exponential model to a scatter plot that looks like it's exponential. Remember to create the function first, y equals a times b to the x minus h plus k, and then adjust in the following order: H, K, A, and B.